Hi, I'm Sophia Tong.
Hi, I'm Roland Van Roy.
Today we would like to introduce you to Richtek's new advanced constant on-time devices.
Let me first explain you some basics of the constant on-time topology.
In current mode buck converters, to regulate the output voltage, we control the on time of the switching waveform to cope with input voltage and load changes, and keep the frequency constant. Constant on-time buck converters control the off time, while keeping the on time fixed. This means that the frequency is variable. The basic COT buck consists of a power stage with driving logic, an output capacitor with some ESR, and the load. A one-shot provides the on time. A high-speed comparator compares a portion of the output voltage with an internal reference. A fixed on time is generated and inductor current rises. When the on time has expired, the low side MOSFET conducts and inductor current drops. Due to the output capacitor ESR, the voltage ripple on the output has a similar shape as the inductor current. Via the feedback network, this voltage ripple is compared with the internal reference. When it drops below the reference, the one-shot is triggered again, and the cycle is repeated, producing a continuous switching signal with an output voltage regulated by feedback network and reference. Now let's see what happens during load transients. We start with steady-state switching. When we suddenly increase the load, the output voltage drops quickly, and almost immediately a new on time is triggered and inductor current rises again. When this is insufficient to reach the new load level, another T-on is generated after a short blanking time. When the new load level is reached, the converter switching stabilizes again. As you can see, COT reaction time is really fast, and this means that the output voltage fluctuation during load transients is very small. Here is a quick comparison between a current mode and a COT buck converter running under the same conditions. A 2 amp load step gives around 60 mV undershoot on the current mode, while the COT converter has only 10 mV undershoot, which makes them ideal for high transient applications like DDR and core supplies, and makes it possible to use smaller output capacitors. One of the drawbacks of COT buck converters is their large frequency variation over operating conditions. Even with defined input and output voltages, a fixed T-on will mean that frequency will have to increase at higher load levels to compensate for the power losses in the MOSFETs and inductor. Competitor COT parts can easily show 25% frequency variation at different load conditions, which can lead to unexpected noise and interference problems. To solve this frequency variation problem, Richtek's advanced COT has added a frequency locked loop system, which slowly adjusts the on time without influencing the fast transient behavior of COT topology. The result is a virtually constant average frequency in all operating conditions, which helps to avoid noise and interference issues due to changing frequencies. Another problem of traditional COT converters is the fact that they need a certain amount of output capacitor ESR to work in a stable manner, normally requiring expensive polymer output capacitors. If you use the cheaper low ESR ceramic output capacitors, the phase shift in the output voltage ripple will result in unstable switching, like the subharmonic oscillation. In order to work with low-cost ceramic capacitors, Richtek's advanced COT has an internal pulse shaping regulator circuit which generates an internal sawtooth with the same shape as the inductor current. This sawtooth is added to the feedback signal and provides the required ripple voltage for stable COT operation. Now the circuit operation no longer depends on the output voltage ripple and is stable with very low ESR ceramic capacitors. Here is an example of a 12 volt to 1 volt 3 amp supply with programmable soft start and power good signal and uses small low-cost components. The small DFN 3x3mm package allows for a very compact layout measuring only 10x10mm while achieving a powerful performance.
Richtek ACOT provides you with constant average frequency, ultra-fast transient response, and is stable with MLCC capacitors. Simple, compensation-free design with low component count makes this a great choice for your new power design. Please visit Richtek website www.richtek.com and do a search for ACOT for more product information, free samples, and technical documents. Thank you.